My name is Robert D. Talbot. I'm a retired electrical engineer who worked for 52 years as a design engineer. I'm going to review now the derivation of time dilation. The above depicts two mirrors and a light source used in the derivation. The derivation derives the time for a light pulse to go up to the top mirror and be reflected back to the source as a tick. If the ship is moving to the right, the pulse will go from the source to A, to B, to C, to D, to E, and F. The light pulse is moving away from the source and will never return and eventually disappear as it runs out of mirror. If an external observer sees a pulse being returned to the source, they see something which is not happening. For a stationary observer at the source, when the pulse was emitted, the pulse will appear to go up and down as the source moves to the right. The path required for a pulse to be returned to the source. The source will go from G and H. The light pulse will appear directly over the source, and the source will be at H when the tick is completed. This requires that the pulse not go directly up, but have a component of velocity and direction the ship is moving equal to that velocity. I don't believe that this can be assumed, and therefore a tick can't be completed, and if it is observed, it isn't happening. Modification to the experiment. The previous two sections showed that the light pulse isn't or can't be returned to the source, which is a requirement for the derivation. Therefore, I'm going to replace the mirrors with a tube with a reflective inner surface, mirrors at the top and bottom with a hole in the center of the bottom mirror for injecting a light pulse. The tube will be placed from the source to K in the original diagram. This will force the light to be returned to its source and cause it to have the velocity component necessary to be returned to its source. In summary, what I'm saying is if you go through the derivation, light can't be returned to its source, which is a necessary requirement. They use external observers to draw the conclusion that it is. And I'm saying, well, if they see it, it's not happening. But you can modify the experiment to make it be returned to the source so that the formula that they derive is right. Determine if the ship is moving. It is assumed that the light source goes directly up. In the middle of ship, place a laser for generating pulses of light. Above the source, place a row of light detectors along the direction the ship is traveling. When the velocity of the ship is zero, the light pulse will strike the detector directly above the source. When the ship moves forward, the pulses will strike a detector behind the center of the ship. The faster the ship is moving, the farther back will be the detectors that the light pulse strikes. This provides an indication of the speed of the ship. I included this because I have been told that a person on the ship would not know that it was moving. Derivation of time dilation. Below we see a diagram of the light path going from S to G to H. The path from S to G will be C delta T sub V over 2. That's half the path. And from G to H is C delta T 0 over 2. So the whole path is C delta T. The path from S to H will be the velocity V delta T sub V, half of it will be S to the midpoint would be V delta T divided by 2. The path from G to halfway down would be C delta T0 over 2. The 2 is because that's for the path at T0, the path going up has to come back down. So that line is half of it. When you look at it, you have two triangles there that are the same. So you can actually use one to do the solution to solve for delta T sub V. You can do that by squaring the hypotenuse side from S to H and setting that equal to the path from G to halfway down between the distance S and H, and the distance from S, half of the distance from S to H. And that's what the formulas down there represent. We have C delta T sub V divided by 2 squared equals C delta T0 divided by 2 delta T sub V divided by 2 squared. The next formula just removes the 2 from all the expressions since it's in every one of the expressions. Next line, the third line down, takes and puts the delta T sub V squared units together. It transformed, and so now it took the last term on the line on on line 2 and brought it over to there. And so now we have delta T sub V squared times C squared minus V squared equals C delta T0 squared, the whole quantity squared. So now I can transform. I'm going to take the C squared minus V squared and divide and move it to the other side of the equation, divide the C delta squared by that. And then I'm going to factor out the C squared from the right-hand side of the equation, and I will then have delta T sub V squared equals delta T0 squared divided by 1 minus V over C squared. Now I'm just going to take the square root, that equation, and so I will now have delta T sub V equals delta T0 divided by 1 minus V over C squared, the square root of 1 minus V divided by C squared, which is the formula used and the formula derived on every derivation of time dilation that you will find. Why have I included this section? Because I didn't follow the deviation but believed the result. I can follow the deviation using the tube. The reason I couldn't follow it is the light couldn't be returned to the source. I added this section in determining the ship is moving because I have been told that a person on a ship can't tell if they are moving. Formula used for time dilation. Delta T sub D, D standing for dilated, equals A delta T0, not dilated. Person who should have been a credible source told me that using space-time, he calculated that the reading of the clock would be 3/5 at V equals 0.8 C, and therefore the time was dilated by this factor. Remember, I stated that time dilation doesn't actually exist, and I believe just about all physicists agree it does. I think his use of space-time assumes time dilation is present, and you can't use something that's based on the fact that time dilation exists to prove that time dilation exists. If there are 3 ticks at V equals 0.8 C and 5 ticks at V equals 0, for the time at V equals 0.8 C to be 3/5 the time at V0, the tick at V equals 0.8, there's a C missing from there, would have to be delta T0. The deviation says that the tick is 5 delta T0 divided by 3, making the time the same, removing time dilation. Also, if a tick was T0, there would have to be 5 ticks at 0.8 C. What I'm doing here is just pointing out the discrepancies. What they've done can't be right. I have been told that some satellites use time dilation formula to make a time correction for their clocks. You can correct the reading of the clock by assuming the reading of the clock is correct and adding time to make up for time dilation. or assume that time dilation doesn't exist and correct the reading of the clock by using the factor A. It is often stated that all moving clocks run slow. In the derivation for time dilation, I conclude that the light clock runs slow because of its design and can be corrected by dividing the output by A, and there is no time dilation. There are those who believe many processes run slow at high velocities. If a clock is subjected to high velocity and it slows down, how can you verify that it is not the velocity that slows it down? I have concluded that if the speed of light is the universal constant, time can't exist, and the explanation for some of these effects may be velocity. Thank you for watching the video. I would appreciate your feedback on the analysis.